All right, turns out we've already talked about measures of location, measures of position. We talked about one last week. We called them quartiles. Quartiles divide a data set into 4 chunks. They tell me whether I'm in the lowest 25%, the highest 25%, somewhere in the middle. So it gives us a way to rank where we are. The problem is it's not super accurate, right? If I'm talking about 400 students, telling me I'm in the top 25 tells me I'm one out of like 100 kids. That's not very specific, yeah? So statisticians want to use a finer gradation of measurements or rankings when we're dealing with bigger data sets, and we call them percentiles. If quartiles divide you into 4 chunks, what do percentiles do? Ooh, how many percents? How many cents in a dollar? 100. Percent literally means per 100, yeah. So percentiles divide our data into 100 equal count chunks. We like it when math makes sense. Because we're dividing it into such fine chunks with so many dividers, we only use percentiles with larger data sets. It wouldn't make a whole lot of sense for me to look at a percentile ranking in a class of 30 students. It would make a lot more sense to use percentiles for the entire senior class of 400. Okay? So I want you to take a minute in your small group and think of instances where you might see percentiles in the real world. And I gave you an example. You might be told when you get your SAT score that your SAT score corresponds to the 85th percentile. That's one example. I'm going to give you about 90 seconds in your small groups to discuss. Other examples of where you'd see percentiles. Food. I am starving. I am starving and I am cranky. Don't judge me. I've had a handful of cereal as the sum total of food today. I'm starving. I don't know. I'm self-conscious. My family was very harsh on me. I figure. If you remind me about midway through class, I can give you fruit snacks too if you like. All right, if you came up with a really good one you want to share, raise your hand. Yes, Katie. Mm. Very good. Often when you go to doctor's offices, particularly for kids, they'll have percentile charts for height, weight, meeting those milestones for growth. For babies, they definitely have it for weight. Very good. What else? Who's got another idea? Show of hands. Yes, Jennifer. Ooh, yeah. STAR test gives you a percentile of how you scored relative to everybody else who took the test. Yeah. Good. What else? You have one, Yari? What do you got? This is very common. No, that's good because it is a common example. And they do it with the SAT, they do it with the ACT, they typically do it with most standardized tests where large numbers of people take them. Anybody else? Yes. I think you're thinking of a percentage or proportion, which is a little bit different. So, and I'm glad you brought that up. So percentiles are a ranking of how much is above and below me. with things like percentage of the city that consider themselves Hispanic, that's a proportion of a whole, not a 57% are better than me and 43% are worse than me. So those percentages or proportions serve a different purpose. And I'm really glad you brought that up, because there is a difference between percentile and percentage, and we're going to talk about that in a minute. But let's get into the nitty-gritty of the definition. So the pth percentile is the data value with p% of the data that is less than or equal to it. Katie used the example of little Timmy at the ninth percentile for height. So I am not judging. So for the example, if I got an SAT score and I was told that I was at the 85th percentile, that means that 85% of test takers had a score that was less than or equal to mine. Meaning only 15% of people did better than you. Yay. There's an asterisk next to that definition. We're going to come back to that in a minute. What I'd like to do is go over a quick couple notes about percentiles, and then we'll do an example so you can see how they're calculated and interpreted. Yeah? Okay. So, first, this is going to come up in your free response. Percentiles are a measure of location. I can be at a location. I cannot be in a location. So when you are talking about percentiles, you would say that my SAT score is at the 85th percentile, not that I am in the 85th percentile. People who are not statisticians confuse those two statements a lot. On the FRQs, the AP board is not going to dock points for that slight slip of the tongue. But remember that those readers are grading thousands of responses. So if they spy small boo-boos like that, they're automatically going to be on high alert for more boo-boos. So you want to use the right wording so that you are not triggering their high beeps, right? Yes, Katie. In terms of the list and locations in a list, I can't be inside of that person. I don't know. It just, it's wrong. It sounds wrong. It feels wrong. You can be in a house, but you wouldn't say I'm right. But when you're talking about, you say I'm at home, not I'm in my home. Feels awkward in English, right? We say I'm at home. You can be in a house. House is a noun. We talk about home as a location. I'm at home. Same idea. So I can be, yeah. And it's weird. And I don't care. I would not mark you. It wouldn't even flip a flag for me if you said in the 5th percentile. But the AP readers, that may trigger them. So just keep an eye out on your language. The other thing is, there was that little asterisk earlier. This is one possible definition of percentiles. If you are studying something that is going to require more statistics, psychology, sociology, nursing, the medical field in general, poli-sci, any kind of social service, you may encounter instances where they define it strictly as a less than. When I say 5th percentile, I mean that 5% of the data is less than my score, not less than or equal to. That changes the math we do. We're doing the lazy man's way. Less than or equal to is easier mathematically to calculate. That's what we're doing. Yay. But you need to read, when you're reading articles or you're in your new math class, you read that textbook carefully and check, because that definition will shift. There are different ways to define percentile. Next thing, when you report it as a whole number. I don't know about you, but it feels weird to say I am at the 84.5th percentile. That sounds gross, right? We want nice, pretty whole number dividers. When you calculate percentile, more often than not, you are going to get a decimal. You should always round it down. Percentiles get rounded down. If 84.5% of the data is equal to or less than me, it is not technically correct to say that 86% is less than or equal to me. That's not true. I've now included some people who are above my score in that statement. That is wrong. So round down. Percentiles go down. Next thing, percentiles and quartiles are related, right? Quartiles divide chunks in half. The 50th percentile is going to divide something in half. So these have a correlation. The 25th percentile should be about what we get for our first quartile. Yeah. My 50th percentile should be about what I get for my median, my second quartile. My 75th percentile should be about what I get for my third quartile, because that's what quartiles do, divide it into quarters. We use quartiles for small samples, makes sense, big chunks. We use percentiles for large samples. What happens if I have medium-sized samples? Ooh, there's a just right measurement in between percentiles and quartiles that doesn't show up on the AP test called deciles. What does that prefix deci mean? 10, yeah, it uses 10 dividers instead of 100. Divides it into 10 equal chunks. So the first decile is the 10th percentile. The second decile is the 20th percentile. It's just using slightly less fine dividers, 10 chunks instead of 100. They won't test you on it, but it's good to know they're out there. So we have the big chunkers for small data. We have the medium chunkers for medium data. We have the large chunkers for large data. Good. The other thing, when you go to interpret your percentile, high percentiles are not always a good thing. On your SAT, you're at the 99th percentile, you want to go brag about that. There are some things you don't want to brag about. So I want you to take a second in your small group and think of things that you might measure a percentile for that are not good when they're high. Discuss. Going to give you about 60 seconds. Examples of things that are not necessarily good to be high. We'll see how far I can walk and how fast I can go. Gummies? 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 Would you like some? Mm-hmm. Gummies? 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 I didn't mean to throw your markers at you. Gummies?
Thank you, Mr. Dollar.
You're welcome. You're welcome. You're welcome. You're okay. Did you make e-haul? Yeah. You're welcome.
From what?
All right, if we could come back together. Raise your hand if you think you have an example of something where it is not great to have a high percentile. Drew, what do you got? Is class rank better to be at a low percentile? I think you're thinking of ranking, but not percentile. You want to be first, but first is not first percentile. That would be 99th percentile. So the ranking and the percentile go backwards for that one. Tricky. Katie, you're looking like you want to say something, and then Vanessa. Katie, what do you got? When we talk about medical things, very often we don't want to be extremely high or extremely low, right? Yeah. Hmm? Ooh, yeah. We would prefer not to have a high crime rate in our city. Blood pressure. Yeah. What else? Ooh. Ooh. I'm trying to think how we turn that into a percentile. Ooh. So that's, yes, a percentage comes into it. That has to do with probability, which we're going to get to in a future unit. Yeah. But health related, and we do see a lot of these in health. I saw, what else did I see? Cholesterol is another big one. You don't want high cholesterol. We know that's not good for you. Good. Very good. So high percentile, not always a good thing. Low percentiles are not always a bad thing. It is important that when you interpret your percentile, you interpret it in context of the problem. Yeah. So make sure that you've read that prompt carefully. Because if we're talking about cholesterol, I do not want to be in the 95th percentile. I was at like the 90th percentile in my 20s. It was not a happy place. They pumped me full of meds and changed my diet. And I'm back. Yeah. And thank my that's genes, by the way. That's my whole family has it. Good. Okay, so we're going to do an example so you can kind of see what a prompt might look like and how we would calculate it if we were interested. So our example says, people are living longer now than at any time in recorded history. This is a blessing, but it's also a challenge for countries because they must adjust to the needs of their aging populations. One statistic important to social scientists who study this phenomenon is life expectancy at birth. The STEM plot shows the life expectancy at birth in a recent year for 41 countries in Central America, South America, and the Caribbean. Calculate the percentile for a country with a life expectancy at birth of 78 years. Interpret this value. So first thing I'm going to do, I don't want to have to write life expectancy at birth every time I got to talk about it, because that's a big old long expression. So I'm going to make a note that I am calling that LEAB. Feel free to giggle. My third period thought it was hilarious. That way I don't have to write out that phrase every time I'm going to talk about it. On the AP test and the FRQs, that is okay to do as long as you define it somewhere so they know what it means. Yeah, because that's a timed test, so shorter is better. Just make sure you define your shortcuts so they know what they mean. So we're talking about the LEAB. We want the percentile for a LEAB of 78 years. And I know percentile means percent of data values less than or equal to. So in that table, I want to mark all of the values that are less than or equal to 78. So 78 is down here. It stops right there. 78. My data starts here at 63. So I need to know how many data values are between 63 and 78 inclusive. So we're going to count. I'm going to give you a minute to do that. How many data values lie in that range? Who's got a number? 36. Yep. So there are 36 data values that are less than or equal to 78 years. I want to turn that data value into a percentage. So if I want to take a count and turn it into a percent, a frequency into a relative frequency, what do I do? And how do I do that? 41 countries. Very good. That's the exact process that we use for relative frequency. Class total divided by total, and then times 100 if you want it as a percent instead of a decimal. We're going to do the same thing here. So 36 divided by 41, and then answer times 100. Oh, I don't know who was using my calculator last, but wow, did they mess things up. Okay. Was it this before you rounded? Oops. Okay. So that's the question. Is that 87 or 88? Always round down. Very good. So this is going to round down to the 87th percentile. Do not just write 87 and walk away. Put it in a sentence. Yeah? A Lieb of 78 years is at the 87th percentile. Free response, they like those sentences. Am I done? No. That set of directions had two verbs. We did the first one, we calculated. What was the other verb? Interpret. Yeah, I have to interpret what that means. So what does it mean for 78 years to be at the 87th percentile? Who can tell me? I know you know. I want somebody else to speak. But thank you for your enthusiasm. I have quiet over here. I have quiet over here. Someone on those edges, give me some information. Frowny face. Ivan, what do you got? How would we interpret that percentile? What does it mean? My brain is a little slow on processing this afternoon. It's not your fault, it's mine. So it is in the top part of the percentiles, right? It's better than 50%. Can we be more specific? If I say I'm at the 87th percentile, 87% of, there's a sentence that goes with that. "78 years is a life expectancy, not a country. 87% of the leaves are less than or equal to 78 years. That does correspond to 70 or 87% of the countries too. Ah, gotcha. So when we're talking about percentiles and we're interpreting, it's the variable of interest, not necessarily the population or sample. So the variable of interest, the data I actually collected from those countries was life expectancies. So 87% of those life expectancies are less than or equal to 78 years. You wouldn't be wrong in saying that 87% of the countries have leaves that are less than or equal to 78 years, but ultimately it comes back to leaves because we were measuring life expectancy at birth. That was our variable of interest. Very good. Before we move on to the next part, questions on what we just did? Yes, Vanessa. Yeah. And you will notice as we work through this course, almost every unit is going to have a sentence frame or set of sentence frames that apply to specific types of problems. That's going to happen all of semester 2. I'm going to give you a set of sentence frames and say memorize it. It works for everything. Yes. Mm. So, okay. And again, they wouldn't dock you for that. It's not technically wrong. The problem when it says calculate the percentile for a country with a life expectancy of 78 years. So this is one random country. I want to know where it falls in the data set I already have. But when I collected this data set and I went to look at my stem plot and I calculated that percentage, what data is here in my stem plot? And not countries. There's not a list of countries in that data set. There is not a count of the number of countries in that data set. There are life expectancies from those countries. I was doing a ranking of life expectancies. Those life expectancies came from countries. You're not wrong. But the ranking isn't countries. Like, I'm not saying when I write that sentence that this country is higher than.
For interpreting the value, take away the context and just look at the numbers, like where those numbers came from.
Look at the variable of interest that you plotted the numbers for. This plot of numbers was this variable. That is the variable that I am doing a ranking of. That is where the percentiles are being ranked. I wanted to look where that 78 sat in a ranking of life expectancies. Right? That's what we marked here, was where is that ranking? Where is that 78 life expectancy boundary? Not where is that country? Where is that 78 years? I'm ranking the life expectancy. It came from a country, but the fact that it came from a country is irrelevant. It's that it's a life expectancy that I'm ranking. No, don't be sorry. No, don't be sorry. This is part of AP Stats. There is going to be a whole lot of wording that you're going to have to parse through. It does. Because the AP board is wordy, and we do not like the people who write the test. No, they really don't, because the test is harder than any of the calculus classes I teach for this class. I hate this test with a burning, utter loathing. It's horrible, but we're going to do our best, because even if the wording is stupid, we know how to do the stats. Identify the variable of interest.
I'm going to try to do that if I wrote like a country with a war is in the age, if I wrote that, would they tell me the incorrect?
No.
As long as I have the number correct.
You have the number correct, and your context relates to the question that was asked. So there is some leeway. Yeah. What I am putting up here is the simplest phrase that will get you a 4 out of 4 on the written. If you don't stick exactly to this, that's fine. But number has to be correct. You have to show the work. Yes, if this part right here was missing, they would not give you credit. And you need to refer to some context from the problem. Life expectancy, countries with a life expectancy of, some wording from the question has to show up in your answer. Good. Okay. Now we're going to go backwards. Yay. So next question. Same data set. We're looking at Lieb's. Says the life expectancy at birth for Peru is at the 39th percentile. How many years is a Peruvian newborn expected to live? For now, I do not care that it is Peru. I care about it's Peru when I go to write my answer. Right now, I care that Peru is at the 39th percentile, which tells me that 39% of the data is less than or equal to whatever Peru's value is. That's what percentile means, yeah? Less than or equal to, less than or equal to. I need to turn that 39% into a count. Where am I in that list? How many data values? So this is undoing that relative frequency calculation. I'm taking a percent and going backwards to a count. What does percent mean? Per what? Per 100. So 39% means 39 over 100. I'm going to take that ratio. I don't have 100 countries. How many countries did I measure? 41. Hmm? No. That's a good question. So we are not adding Peru to the list. We are seeing where Peru would sit if we had the value for Peru. Where would Peru match up with? Mm-hmm. Sort of like little Timmy's not in that percentile at your doctor's office, but they still rank it. Same idea. Yes, you may go. On your calculator, because you guys are wonderful AP Stat students who all brought your calculator to math class today. What do you get when you do that? 15.99. This is not a percentile. We round this to the nearest whole number, which is 16. This is not a percentile. That was a percentile. This is not a percentile. Rounded to the nearest whole number. This is a count. Where am I sitting in the list? This number is answering the question, where am I sitting in the list? What I need to do to get the actual leab that goes with the 39th percentile is I need to figure out what is the 16th value in the list. I'm going to go back to my list and I'm going to count until I find the 16th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. When I land at the 16th value, what is my leab? 72. So if Peru is at the 39th percentile, Peru has a leab of 72 years. Because that's what it means to be at the 39th percentile in this country's ranking system. Based on this data from Central South America and the Caribbean, if I'm at the 39th percentile, that corresponds to a leab of 72 years. This is the same calculation we used on our frequency table to get back and forth between frequency and relative frequency. The percentile calculation was how we got from a count to a percent. This is how we got from a percent back to a count, but then we have to figure out where that count sits in the list of ordered data. Because it's going to tell me how many data values are less than or equal to me. I need to figure that out. Where am I in the list? Yeah? Fun times. Okay, we've got one more thing I want to start today before I set you loose. We're going to start with an example. Last summer, I taught 2 college intro to stats sections over the summer because I am sick and I decided I'd rather make money than have a break. The first section, their mean final exam score was 72 with a standard deviation of 11.5. The second section, which was slightly smaller, had a mean exam score of 75 with a standard deviation of 9.8. One had a lower mean but was more spread out. One had a slightly higher mean, but the data was clustered closer together. Max is in the first section. He got an 83 on his final. His friend Maria is in the second section. She got an 85 on hers. Who did better? And the answer is comparing their scores right now doesn't tell us anything because they came from different distributions. I need to know how well Max did relative to Max's class and how well Maria did relative to Maria's class. To do that, we are going to use something called a standardized score. In Math 3, you may have called them Z-scores. Yeah, they came back. And that chunk on the normal curve, that's coming back on Friday. But being taught by a statistician. So hopefully it'll make more sense. Yeah, the bell curve. What a Z-score does. A Z-score looks at how far you are sitting from the mean. How far am I from the average? So we're going to take the data value and we're going to subtract the mean to figure out how far away we are from the center. We called that the deviation last week when we learned about standard deviation. How far am I from the middle? And by itself, that doesn't necessarily tell us a lot because there were two different measures of center. Max and Maria's means were different. In order to standardize them, I am going to change that count by 1% each into a count of standard deviations. How many standard deviations am I from the mean? Z-scores answer the question, how many standard deviations am I from the mean? It's measuring a distance from the middle, but it's counting in number of standard deviations instead of number of hash marks on a number line. It removes the mean and standard deviation as factors in their test scores so that then I can compare across those different classes. Yeah, I do this when I'm curving sometimes, if my classes have wildly different spreads. So we're going to do that calculation for Max and Maria. I'm going to start with Max, and then I'm going to have you guys do Maria's. So for Max, what was Max's final exam score? 83, yeah, there we go. So Max got an 83. What was the mean in his class? A 72. He was 11 points above that mean. And what was the standard deviation? 11.5. Very good. If you do that on your calculator all at once, remember to put parentheses around the numerator. When I do it, I get 9.5, I want to say 9.56 something, 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 something. And I'm going to round it to 2 decimal places. And you will see why on Friday. But there is a reason for it. Not just for funsies. So Max is a little bit less than 1 standard deviation above the mean for his class. I want you to repeat that for Maria. What is Maria's Z-score? This should be fast. I'm only going to give you like another 45 seconds. Let's see who's fast on their calculator. I saw Drew clap his hands. What did you get, Drew? 1.02. Did anybody else get 1.02? I'm getting some thumbs up and some nods. Very good. So Maria got an 85. Her class average was a 75. Her standard deviation was a 9.8. Yes? Of those 2 Z-scores, who did better? Maria. She is further from the mean than Max is from his mean. All right, when I see you tomorrow, we're going to pick up where we left off. If you have questions on the homework that's due today, I'll be around until 5. Yay. Good work today.